Hello guys, how are you doing? So limit as x tends to 0 of 1 over x raised to the power 2 over x. There's the standard limit pattern. It's very standard. If you have limit as x tends to 0 of 1 plus x raised to the power 1 over x, then the answer is what? E. Are we together? Euler's number. The answer is E. Please take note of that. We have another standard limit. If you have limit as x tends to okay, when we get to that question, don't worry, it's the question is here. So without wasting much of our time, limit as x tends to 0. So we are going to change this guy to what? Of what? 1 plus x raised to the power what? 1 over x multiplied by what? 2 over 1. You know it's the same thing. Am I right? Isn't it? This guy is same thing as this. But I want to follow this standard rule that says as your x shrink to 0, 1 plus x raised to power 1 over x shrink to what? E, Euler's number. So at the end of the day, the answer is equal to what? E raised by what? 2. That's that for that. You can also use another method, but I use standard limit now. Let's use another method. Now, let's say our L or our Y, let's say Y equals to limit as x tends to 0 of what? 1 plus x raised to power what? 2 over what? 2 over x. No, this is the question. Let's say the question is equal to y. Now, take ln of both sides. If you take ln of both sides, what do you have? You have what? Ln y equals to what? Ln 1 plus x raised to power what? 2 over what? 2 over x. So you have what? Ln y equals to what? 2 over x ln 1 plus x. Let me space. I'm coming. So we said we stop at ln y equals to what? 2 over x, right? Multiply by ln 1 plus x. I think that's where we stop. So we can conclude that ln y equals to what? 2 ln 1 plus x over what? Over x. Is that clear? We also have another standard limit that says ln 1 plus u over u as u tends to 0 equals to 1. It's also a standard limit. Ln 1 plus u over u as u tends to 0 equals to 1. This is it. Let me also give you another standard limit. Ln 1 plus u alone as u tends to 0 equals to what? U. Are we together? Ln 1 plus u as u tends to 0 equals to u. Take note of that. So if this one equals to u, then u over u is 1. These are standard limits you need to know. This one you can use L'Hopital to prove that this is 1. But these are standard limits that you need to know. Very important. So that means ln 1 plus s over s equals to 1. So we can conclude that what? Ln y equals to what? Equals to 2 times 1. 2 times what? Ln 1 plus x. Sorry, ln over what? Over x. So ln y equals to what? 2.1. So ln y equals to what? 2. So how do we remove the ln? We take exponent of both sides. So exponential ln y equals to what? Exponential what? 2. If you have e raised to power ln 2, the answer is what? 2. Because e raised to power ln is ln cancel in e rather. Are we together? So e raised to power ln y is equal to y. So our y is equal to what? E square. So that's what we obtain here. So the second one, limit as x tends to 0 of 1 plus 3x raised to power 1 over. Before I take ln of both, okay, let me take ln of both sides. I can also use standard limit here. Yeah, I will still use standard limit. So taking, let's say y equals to what? Limit as x tends to 0 of what? 1 plus what? 3x raised by 1 over 5x. Is that clear? So I can conclude now that take ln of both sides, you now have what? Ln y equals to what? Ln y equals to limit as x tends to 0 of what? Of ln 1 plus 3x raised by 1 over what? 5x. Is that clear? So you can conclude that ln y equals to what? Limit as what? As x tends to 0 of what? 1 over 5x ln 1 plus what? 3x. Is that clear? So come and see what you want to do here. You have to be able to think. Now you can see the standard limit. if you have 10u here, once it is also over 10u, then the answer is equal to 1 as u tends to 0. If I say ln 1 plus 50x over x is not 1, but if I say over 50x, the standard limit is equals to 1 as x tends to 0. If x is tending to infinity, then it can be another answer. We'll get there. So we can see, how can I turn this guy to 1 now? It's going to give me ln y equals to what? Limit as x tends to 0 of what? 1 over 5x ln what? Ln 1 plus 3x, are we together? Multiply by 3 over 3. If I say 3 over 3, that's just 1. It has not changed anything. Now look at it. So ln y equals to limit as x tends to 0 of, now this 3 times 1, we have 3, are we? 3 times 5, we have over 5. Am I right? So, oh, sorry, let me not use that. Still put this 5 here, sorry. So multiply by what? Ln 1 plus 3x, 1 plus 3x over what? 3x. Do you get what we did here? You know, this is 3. 3 times x, this is the 3x. This 5 is still here. 3 times 1, this is it. Do you get what we did now? I multiply up and down with 3 over 3, which has not changed the question because 3 over 3 is just 1. So now using this 3 to multiply this one, you get this. Using 3 to multiply x, you get over 3x here. Then this 5 remain there. So our ln y equals to limit as x tends to 0. Now, this guy now standard limit, since we have 3x here, is equal to what? The answer is equal to what? Is e. I mean, it's 1 rather. See, this is the standard limit, equals to 1. Is that clear? So here we are going to have, what? Equals to what? 3 over 5 multiplied by 1. Are we together? Since we've used our limit, we don't even need, sorry, we don't need this again. So as your x tends to 0, then ln y becomes what? 3 over 5 times what? Times 1. As x tends to 0, this one becomes 1. So ln y equals to what? 3 over 5. So y equals to what? E raised to power 3 over 5. Is that clear, please? So that's our y. You take exponent of both sides, you get e raised to power 3 over 5. You have to master those standard limits because they are very vital and very important. Now, limit as x tends to infinity of 1 plus 2 over 5x raised to power x. Now, take note. A standard limit says limit as x tends to infinity of what? 1 plus, let me say, I'm coming. 1 plus n over x raised to power x equals to e raised to power n. As x tends to infinity, see, don't confuse this thing together. If x tends to 0, something like this gives you a standard. You know, I use standard limit. I'm using two method to solve all the one I've solved. I use 2 methods. I use standard limit. I also take ln of both sides. So you can use standard limit direct. You can take ln of both sides. So just know the properties. Well, during our live class, a lot of things are going to be discussed. I don't want you to cram this thing. You have to just understand the property. When your x is tending to 0, 1 plus s raised to power 1 over x, we tends to e. We tends to e. And there is a reason for that. In fact, through this method, it has been proved that it tends to e. So this one too, if you have something like this, as your x tends to infinity, see, this is a standard limit. If a is here, this will be e raised to power a. Are we together? So here now we can conclude that our n equals to 2 over 5. Why? Because 2 over 5x is same thing as 2 over 5 over x. So this guy can turn to 1 plus 2 over 5 over x raised to power x. If you have to follow this pattern, so you have e raised to power 2 over 5. Is that clear? Is that clear? So this guy gives us what? The answer is e raised to power 2 over 5. That's the answer. Standard limit. I don't think if you get what I'm saying. This, our n here is 2 over 5 because 2 over 5x is same thing as 2 over 5 divided by x. So, and you see the standard limit. As this one is for infinity, As x tends to infinity of 1 plus n over x raised to power x, then your answer is e raised to power n. Now, standard limit. Now, let me take lane of both sides. Now, taking lane of both sides, let's call this y. Y equals to limit as x tends to infinity of 1 plus what? 2 over what? 5x raised to power what? Raised to power x. Now, take lane of both sides. You have lane y equals to what? Limit as x tends to infinity of what? Lane 1 plus 2 over 5x. Are we together? Raised to power x. So you have what? Lane y equals to what? X lane. Is that clear? X lane. Lane y equals to, lane y equals to limit, always add your limit as x tends to infinity of what? X, x will come down. X, some of you that don't know lane this stuff, I pity. If you have lane 2 square, it becomes 2 lane 2. So that's what we do here. What lane and log does is that they bring down power. So that's it. There's no space here. Let me manage it. So here we have what? Lane y equals to what? Limit as x tends to what? Infinity of what? X lane what? 1 plus 2 over what? 5x. Is that clear? So how do we deal with this now? Now, this guy now give us lane y equals to limit as x tends to infinity of what? Lane 1 plus 2 over 5x. Are we together? Over 1 over x. Do I even need this? I'm coming. Okay. Yeah, this is where we have gotten to. Now there is something we are going to do. We are going to say, I'm coming. Oh, let u equals to 1 over x. Are we together? This denominator. If your u equals to 1 over x, if you cross multiply, that means x equals to what? 1 over u, isn't it? Now let's leave this on aside. Let me write it here. So because we need to see it very well. Yeah, I stop at what? Lane y equals to limit as x tends to. In fact, if you're unable to solve much question today, because as I'm explaining this, time is going. If you understand all this pattern, you are good to a point. Are we together? So it's equal to limit as x tends to infinity of what? Lane 1 plus 2 over 5x divided by what? 1 over what? 1 over x. So let u be equals to 1 over x. Do you know why we need another substitution for that? A substitution rather. Because if you input infinity direct, you have a 0 at the denominator because 1 over infinity is 0. So it will be undefined. So we have to look for another way. Now, as x tends to infinity, then u tends to 0. Am I right? Because if you say let u be 1 over x, 1 over infinity is 0. So this limit is going to change. It's going to change. Now, come and say how it's going to change. Now, before then, if u equals to 1 over s, what is x? X is what? 1 over what? 1 over u. That means 2 over 5x that we have here, since x is now 1 over u, is going to give us what? 2 over 5 multiplied by 1 over u. Do we get? Which will be what? 2 over 2, which will be what? 2 divided by what? 5 times, our x is 1 over, if u is 1 over x, if you cross multiply, x will be 1 over u. So 2 over 5x will be 2 over 5x, 1 over u. That will be 2 over 5 times 1 over u. That's what? 5 over u, which is 2 multiplied by what? U over 5, which is what? 2u over what? Over 5. So this whole question will change to lane y equals to limit as u tends to 0. You are no longer using x now. So all the x here will change to u. As u tends to 0 of what? Lane. Because as x tends to infinity, what happens to u is 0, because we say u equals to 1 over x, 1 over infinity. Lane 1 plus, now this 2u, 1 plus what? 2u over what? Over 5. 2 over 5x is same thing as 2u over 5 if u equals to 1 over x over what? Over u. Do we get this? Our 1 over x is u. Can we move on? Now, there is another standard limit. Not actually another, still the same thing. as x tends to 0 of ln 1 plus x, the answer is what? X. So this numerator, let's focus on this numerator. As u tends to 0 of ln 1 plus 2u over 5, what do we have? The answer is what? 2u over 5. Please take note of that. It's still this pattern. Ln 1 plus s equals to s as s tends to 0. So ln 1 plus 2x over 5 equals to 2s over 5 as what? As x tends to 0. So that's that for that. So this guy is going to give us ln y equals to, since we're using our limits, we've already said as u tends to 0, this becomes 2u over 5. Are we together? So what are we going to get? We are going to get 2u over 5. Are we together? Divided by u. We have a u there. So I'm going to multiply the numerator and the denominator by 2 over 5. So it's going to give me 2 over 5 divided by 2 over 5 divided by 2 over 5. I've not changed anything, because this over this is just 1. 1 times this is still this alone. So I've not changed anything. So now ln y equals to what? Limit as u tends to 0 of what? 2 over 5 times this, you have what? 2 over 5 ln 1 plus what? 2u over what? Over 5. 2 over 5 times u, you get 2u over what? Over 5. Do we remember the standard limit, that limit as x tends to 0 of what? Ln 1 plus x over x equals to 1. Yeah, standard limit. Where did I write it, sir? Where is that question? This is it. Standard limit. Are we together? So this guy now equals to what? 1. So you can conclude that ln y equals to what? Limit as u tends to 0 of what? 2 over 5 times what? Times 1. We have already used our limit. We don't need to write it again. As u tends to 0, all these become 1. So we are not putting limit again. Ln y equals to what? 2 over 5 times 1? 2 over 5. So e raised power ln y equals to y. E raised power d, e raised power what? 2 over 5. Using standard limit is very interesting. It's not just know when x tends to 0, when x tends to infinity, some standard limit that will give us, very, very important. So try this. Drop the answer in the comment section. Yeah, you can also do your whatever here. Now let's move on. Try this one and drop your answer in the comment section. So now number 5, we have limit as x tends to 0 of this. You are going to use what? Rationalization. If you do direct substitution, you get 0 over 0. So by rationalization, you rationalize using the numerator. So this guy gives us limit as x tends to 0 of what? Root 1 plus x minus root 1 minus x over x times root 1 plus x plus root 1 minus x over what? Root 1 plus x plus root 1 minus x. You use the numerator to multiply up and down, but you are using the conjugate now. That is, the sign will change. So it's going to give us limit as x tends to 0 of root 1 plus s times root 1 plus s. That give you 1 plus x, right? Root 1 minus s times root 1 minus s. Don't forget this minus. It gives 1 minus s, right? I told you, whenever you are doing difference of two squares, something like this. Yeah. The middle one, don't bother. They will cancel out. Just say first times first, second time. That is if they are the same, and the signs are different. If this is the same thing with this and the second is the same thing with the second, but they have different sign, plus, minus, then you can say this times this, then this times this. That's your answer. Because if you do this times this, it will cancel out. It will cancel out. If you do this times this, it will cancel out this times this. Is that clear? So over, what do we have here? X into what? Root 1 plus x plus root 1 minus x. So here we have what? Limit as x tends to 0. 1 plus x minus 1 plus x. If you open the bracket, minus 1, minus times it plus x, over what? X into root 1 plus x plus root 1 minus x. I don't want to open this bracket here because I will still cancel out this x, equals to limit as x tends to 0 of what? 1 minus 1 is 0, x plus s, 2x, over what? X into root 1 plus x plus root 1 minus x. So s cancel x. So I have limit. So s cancel x then is changed to what? Limit as x tends to 0 of what? 2 over what? Root 1 plus x plus what? Root 1 minus x. Oh yeah, input your 0. 1 plus 0. Now as x tends to 0, input because of space. Then you have 2 over 1 plus 0, that's 1, root 1 plus 1 minus 0, root 1. So you have 2 over root 1 plus root 1, that's 1 plus 1, that's 2. As you put 0, so you have 2 over 2. Then your answer is what? Your answer is 2 over 2, that's 1. Put your 0, you get root 1 plus root, because this 1 minus 0, which is 1, root 1, 1 plus 0, 1, root 1 plus root 1, that's 1 plus 1, because root 1 is 1, that's 2. So 2 over 2, you get 1. So this one too, we've done something like all this rationalization in the previous video. Do this, send the answer in the comment section. We will talk about it on the comment section. This one too, rationalize this plus 2s. Rationalize, send the answer in the comment section. And number 7, rationalize, send the answer in the comment section. We've done rationalization. Like I did it very well in the previous video. Maybe you should go and watch it. So 1, 2, 3. The reason why I said I shouldn't have included this, but something like related to this, I want to see how you can get rid of this. So that's why I put this as class up to drop on the comment section. So all these are bonus. So let me treat number 8. Now limit as x tends to 0. Limit as x tends to 0 of this guy. Now what am I going to do? Let me first find the LCM. So what's the LCM here? 8, right? So I'm getting 8. This over 1 in 8 times this is going to give me 8 root what? 1 plus x. This over 1 too. I'm going to get minus 8. 2 in 8, 4. 4 times minus x minus 4x. 8 in 8, 1. 1 times s square plus s square over s cube. I hope you are not confused. What's this? These are down. All this over 1 over 1. The LCM is 8. 1 in 8, 8 times this, you have it. 1 in 8, 8 times this, you have it. 2 in 8, 4 times this, you have it. 8 in 8, 1 times this, you have it. So is that clear? So this guy is going to give us what? Limit as x tends to 0 of what? Of 8 root x plus root 1 plus x minus 8 minus 4x plus s square divided by 8 8s cube. I hope you agree. Because if I say divided by 8, then divided by s cube over 1, that will be multiplied by 1 over s cube. So I will still have, if you have 2 over 2 over 3, same thing as 2 over 2 times 3. So that's it. So what are we going to do? Can I put my 0 direct? No, I cannot put it direct. And I'm thinking of how not to use the L'Hopital's rule. I'm thinking of that. Yeah, I think I don't have a choice. So I've rewritten the question here. I think I don't have a choice than to use the L'Hopital's rule. So we are going to differentiate. So seeing something like this, you are differentiating 3 times so that you don't have 0 here. Now let's differentiate the numerator. Note, if you differentiate root 1 plus x, is same thing as 1 over 2 root 1 plus x. So this guy is going to give me limit as x tends to 0 of what? 8 multiplied by, oh, this is even 2 stuff. Product rule. We are going to use product rule. So that's v du over dx, right? V, this my u, this my v. My v is this, 1 plus x. V du over dx is 0 if you differentiate 8. So multiply by 0 plus u dv, 8. U dv over dx. If you differentiate v, you get 1 over what? 2 root 1 plus x. Are we together? If you differentiate 8, you get 0. If you differentiate minus 4s, you get minus 4. If you differentiate s square, you get 2x over what? 8s cube. So you get limit as x tends over, sorry, you differentiate 8x cube, you get what? 24x square. 3 times 8, 24. So this gives us limit as x tends to 0 of what? This one turns to 0. You have 8. Now, 2 here, 1. 2 in 8, 4. So you have 4 multiplied by 1 over root what? X, 1 plus x. 1 plus x minus 4 plus 2x over what? 24 x squared. If you put your 0 direct, you still get 0 at the denominator. So we are differentiating the second time again. So it's going to give us limit as x tends to 0 of, now this also product rule. I don't want to, should I make it, okay, let me make it quotient rule. You know, the question we have here equals to, should I make it quotient? Yeah. Let me make it quotient. You know, 4 times 1. Here we have what? 4 over this. So what I have here, I'm not using quotient rule for everything though. L'Hopital will say differentiate the upper one separately and the down one separately. But one of the upper one is in fraction. That's why I want to use quotient rule for that. This is my u, right? And this is my v. Don't forget, quotient rule says v du over ds minus u dv over ds over v square, isn't it? So quotient rule v root 1 plus x v du over ds is 0. Are we together? If I differentiate 4 minus u dv over dx. If I differentiate 1 plus x, I'm going to get what? 1 over what? 2 root x. 2 root 1 plus x rather. You can write it on your note and differentiate. If you differentiate v, the denominator, you get 1 over 2 root 1 plus x. This over v square. What's our v? Root 1 plus x. Root 1 plus x square. If you differentiate 4, you get 0. If you differentiate 2x, you get plus 2. Am I right? Over, differentiate 24x square, you get 48x. Are we together? So if you still put your 0, you still get what? Quotient rule is v, you know, the upper one is u, the lower one is v. Quotient rule says v du dx. Du dx, if you differentiate 4, you get 0. Minus u, 4. dv dx, if you differentiate root 1 plus x, you get 1 over 2 root 1 plus x over v square. So our v is root 1 plus x, the square, you square it. Is that clear? So this, if you put your 0, you can't, you still get 48 times 0, you still get 0 here. So you change to what? Limit as x tends to 0 of, let me just rewrite it. This one turns to 0. What do I have left? 2 here 1, 2 here 2. So here becomes minus 2 over what? Root 1 plus x. For questions that are demanding like this, they can specify that we use L'Hopital's rule. Over, what do I, this square cancel root, right? So this one becomes 1 plus x multiplied by what? 48x. Don't forget what I told you. If you have 2 over 2 over 3, it becomes 2 over 2 times 3. So this over this over this becomes this over this times this. So that's what I have here. No square will cancel root here. So at the end of the day, we are going to what? Differentiate for the last time. Are we together? Now the third, using L'Hopital's rule the third time. So it's going to give us limit as x tends to 0 of what? V, this fraction, quotient rule. V 1 plus x du ds, if you differentiate the up, is 0. Minus u minus 2 dv ds, if you differentiate the down, 1 over 2 root 1 plus x plus 2 becomes 0. If you differentiate plus 2, you get 0. This one is product rule. This 2 is product rule. And product rule is v du over ds plus the difference between over v square. Over v square, you know it's quotient rule. V du ds minus u dv dx over v square. Root 1 plus x square. Everything divided by. Now this product rule. V du ds plus u dv ds. Quotient rule is minus, then over v square. Plus product rule. V du ds plus u dv ds. V du ds. V 48x. The first one is u, the second one is v. 48x. V du ds. If you differentiate 1 plus x, what do you get? 1 plus u 1 plus x dv ds. If you differentiate 48x, what do you get? 48. Right? So this now it becomes limit as x tends to 0 of this one turns to 0. Here 2 cancel 2, am I right? Minus times minus plus. What do you have left here? 1 over what? Root 1 plus what? Plus x. Is that clear? Divided by, no, here square cancel root, right? Divided by 1 plus x. Yeah, Is that clear? Divided by 1 plus x, then divided by this 48x times 1, 48, plus what? Plus 1 plus x into what? 48. I use this to multiply this, like 2 over 2 over 3, same thing as 2 over 2 times 3. So this over this over this, same as this over this times this. Since this cancels, this 1 plus x times this, that's what we have here. So 48x times 1, oh, that's 48x, not 48. So now as x tends to 0, what do you have? The numerator becomes what? 1 over root 1 plus 0, which is root 1, which is 1, right? The denominator becomes what? 1 plus 0, right? That's still 1. Open bracket, 48x, 48 times 0, that's 0. Plus, is that clear? Plus another 1 plus 0, that's 1. Times what? 48. Are we together? So this guy give us 1 over 1, that's 1, right? Divided by 1 into 1 times 48, 48. So we get what? 1 divided by what? 48. That's the answer. Please be calming down whenever you are doing L'Hopital stress. Like even when you are doing it more than once or twice or 3 times. So the next question. So answer for that one is 1 over 48. So for this one now, we have limit as x tends to 0. You know this guy is the same thing as limit as x tends to 0 of 6 plus x square minus 6 square over x. These two are difference of t square. And don't forget difference of t square, which is a square minus b square. A square minus b square equals to what? A minus b, a plus b. Do we remember? So that's difference of 2 square. So this guy is going to give us limit as x tends to 0 of what? 6 plus x minus 6. You know our 6 plus x is a minus b, a plus b. 6 plus x plus 6 over x. Now this is in brackets, just like one thing. A minus b, same a square minus b square equals to a minus b multiplied by a plus b. So a minus b multiplied by a plus b. Do we get? So it's equal to limit as x tends to 0 of what? 6 plus x minus 6 cancels 6. Here we have what? X multiplied by 6 plus 6, 12 plus x, right? Over what? Over x. So this cancels. So it equals to what? Limit as x tends to 0 of what? 12 plus x. So as your x tends to 0, you have what? 12 plus 0 equals to what? 12. That's clear. So this one, if you do direct substitution, you get indeterminate or undefined stuff. So now we continue. Limit as x tends to 0 of, find the LCM. What's the LCM? The LCM is what? X into x minus 5. Yes. X in this, you get this, times 1, you get x minus 5. Plus, some people with LCM is this times this, x square into no. Since x can still go in this, so your LCM is just only this one. Are we to get the least common multiple? So this in this, you have s alone, s times 5, 5x. Is that clear? So it becomes limit as x tends to 0 of what? Let's open the bracket. Do we have to? Yeah. X, I'm coming. So that's x minus 5 plus 5x over x into x minus 5 equals to limit as x tends to 0. X plus 5, that's 6x minus 5 over what? X over x into x minus 5. So what are we going to do? Okay, this x minus 5. So this, I'm coming x minus 5. 6. I'm checking something. Okay, let's see. Limit as x tends to 0. If I should bring out 6, if I should factorize 6 out, okay, it won't go. Tungo. I'm trying to think of something, but since the thought cannot come as soon as possible, maybe I'm not seeing it. And the way I'm looking at it seems there's nothing hard there. So I think it's better because of our time. Let me just use L'Hopital's rule. So since we stop here, if you put your x direct, you are going to get 0 at the denominator. Now using L'Hopital's rule, using L'Hopital's rule, differentiate the upper. It's going to give you limit as s tends to 0. If you differentiate 6s, you get 6. If you differentiate 5, you get 0. Now this one is same thing as x times x, s square, right? X times minus 5, minus 5x. So you are differentiating s square minus 5x. So if you differentiate s square, what do you get? 2x. If you differentiate minus 5 here, you get what? Minus 5. If you still put yours, okay, we can put our 0 now. So as x tends to 0, we get what? 6 over 2 times 0 minus 5 equals to what? 6 over minus 5 equals to minus 6 over 5. Are we together? So the next one, limit as x tends to 0 sine 2x over x. There's a standard limit that says as x tends to 0, sine x over x equals to 1, tan x over x equals to 1, cos x over x equals to 1. All the trig over x equals to 1. Are we together? As your x tends to what? Tends to 0. Is that clear? Like sine, is it all the trig? Sine, cos, and tan. I'm sure of those three. I will confirm if it's all the trig. Whether cot, sec, whether... I think it should be all the trig. Yeah. But I'm going to confirm. Yeah, it's, with sec, we'll get... Let me confirm. Yeah, all the trig. Whether sec, or cosec, or cot, or cos, or sine, or tan. Tan x over x is 1 as x tends to 0. Same thing with all the trig. Cot x over x equals to 1 as x tends to 0. Even cos 50x over 50s is also 1. Once the angle here is same thing as the denominator equals to 1, but this one is not the same. So we are going to do something there to make it the same. You can use L'Hopital's rule, but if they don't ask you to use L'Hopital, all these questions, they don't need L'Hopital's. If you differentiate sine 2x, you get 2 cos 2x, you get 1 here. 2 cos 2x, if you put 0 as x, you get 2 over 1, you get your 2. But we don't need to use L'Hopital's rule. So how do? We multiply the numerator and the denominator by 2. So it's going to give us what? Limit as x tends to what? 0 of what? Sine 2x over x multiplied by 2 over what? 2. You know we have not changed anything because this is just 1. So it's going to give us limit as x tends to what? 0 of what? 2 sine 2x over what? 2x. Now as x tends to 0, sine 2x over 2x equals to 1. So your final answer is equal to 2 times what? 2 times 1 equals to what? Equals to 2. Can you see that? So for this guy, you can use L'Hopital's rule and differentiate, but I don't want to use L'Hopital's rule. Yes. Let me say, let h be equal to x minus pi. So if h equals to x minus pi, then I can conclude that what? X equals to what? H plus what? Plus pi. If I make s the set of the formula, it becomes... So I can write... Now, if h equals to x minus pi, are we together? So as x tends to pi, that means h will give us what? Pi minus pi, right? As x tends to pi. Since I say let h be this, and as h equals to this, as x tends to pi, h will give us pi minus pi. That means h will tends to what? 0. So the whole limit, this substitution now, you know I've used it once then, that u. So the whole limit will now change to what? Limit as h tends to 0 of 1 plus cos x. You know what's my x now? H plus pi. How do I get that? I say let h be this. Then I make s the result of the formula. So I'll now get the cos what? H plus pi. Is that clear? Over. Can use L'Hopital's rule, but learn all this. When you are growing your idea with all this, then limit becomes more interesting to you. Over, and sometimes they can specify that do not use L'Hopital's rule. So if you don't know all these things, you will just be looking. So what's our... We say let h be this. So that means this will be what? H square. This question is not this question, but you see, I've just changed it, but it's still the same thing. If I say let H be this, then everything, my limit will change. Because if H equals to this, as x tends to pi, that means H will be pi minus pi, H tends to 0. So also note that cos H plus pi is same thing as minus cos H. Yeah, I think that should be right. Yeah, that's strict. That's right. If you want to check, assuming our pi is 180, we are not assuming. Assuming our H is 30, cos pi is 180. Take note, we all know that. So 30 plus 80, 180, that's 210. Cos 210 is minus cos 30. No, cos H plus pi equals to minus cos H. Try it in your calculator. See, assuming our H is 30. If our H is 30, that means this is cos, since pi is 180, that means this is cos 210. So I want to show that I want to show that cos 210 is minus cos 30 if my H is 30. So cos 210, you can see cos 210 is what? Minus 0.8666. What's cos 30? Cos 30 is minus cos 30 is 0.86. So minus cos H plus pi. Cos anything plus pi is minus cos of that anything. So that means this one change to limit as H tends to 0 of what? 1 plus minus cos H. This is the same as 1 minus what? Cos H over what? H square. Very interesting. And also don't forget, as H tends to 0, cos for every small h rather, once h is very very tiny, very small, cos h is same as 1 minus h square is approximately 1 minus h square over h. I don't want to use L'Hopital. So you have to know something. You can use L'Hopital and get your answer. There's no problem. That's why I'm doing all this. You know how to use L'Hopital. Differentiate this. If it still resolves to undefined, you still differentiate the second time. See, if your h is very small, do I need to be try it in your calculator, then cos h is what? 1 minus h square over h. If your h is very roughly approximately equal. So let's say my h is 0.00001. Cos 0.000001. That's 70 equals to dash, so that gives me give me 1. Are we together? See, cos 0.0001. The calculator say it's 1. So is 1 equal to 1 minus h square over h? Of course, it's roughly equal because this my h is 0.0000001 square divided by h 0.0000001. This is it. So 1 minus answer, you get 0.99999, which is roughly 1. So cos h, as h becomes very small, cos h equals to 1 minus h square over h. So this guy, are we together? So this guy give us limit. So this guy turns to, do we even need to I'm coming. I want to check something. I'm having something here. If as h becomes small, this equals to this, then I also must apply that as h becomes small to my denominator. I don't think you get what I'm saying. If cos h equals to 1 minus h square over h, not for every h. If it is for every h, we can only apply that to the numerator and still continue and cancel out. But it's not for every h. Assuming it's for every h, it would have been better. Because if h is 30, cos 30, 0.86, it's not the same as 1 minus 30 square over 30. 30 square is 900. Over 30, that's 30. 1 minus 30 is 0.86. So this is only valid for every small h, which means we have been taking our limit already. That is, as h tends to small value. Are we together? As h tends to small value, very tiny, then this is equal to this. So that means if I'm applying that rules to the numerator, I must also apply it to the denominator. I was not even looking at that before. So just like the earlier one I told you about. So if I apply it to the denominator too, as my h tends to 0, then I'm going to get undefined. So I'm checking what to do, and I don't want to touch L'Hopital's rule. I don't want to touch it. If I'm to use L'Hopital's rule now, this is not add again. I just differentiate the up, differentiate the down. Then I get here, I get sin h. Because if I differentiate this, I get 0. Cos h equals to minus sin h if I differentiate. But if I differentiate minus cos h, I get sin h over 2h. I will still get 0. I will have to differentiate again. If I differentiate sin h, I get cos h. If I differentiate 2h, I get 2. I have together. So cos h over 2, that's cos 0 over 2, that's 1 over 2. The answer is 1 over 2. But I'm looking for the answer is 1 over 2. I'm looking for a way to do a manipulation here without using L'Hopital's rule at all. I'm trying to remember the manipulation to do here. Please take note. We understand to this point, thank God, fine. And for every small h, as h tends to 0, cos h equals to this. Are we together? Cos h can be equal to this. Do you know why we have to bring this in? Because of this h squared. But I have to apply this limit to the downward part too. So stop here for now. I don't want to use L'Hopital for this question. I'm forgetting some things. I don't want to use L'Hopital. Skip it. I'm coming back to it. The question I gave you, have to drop it on the comment section. But me, myself, I will finalize this on the comment section without L'Hopital's rule. Limit as h tends to 0 of 1 minus cos h over a square. If you don't understand to this point, in fact, you can still skip this for now. If you don't understand to this point, back the video and listen to everything, then grab it to this point. Immediately, once I'm done with the video, immediately, I will finalize this guy, then and drop it on the comment section for you. Please check it, please, because it's very important. You have to master some method before. It's been a while I've done it, and I don't actually revise it much. It's been a while. This like almost get to a year now. That's when I was in 100 level, and I'll be going to 200 level now. So please just keep this guy. I will drop it on the comment section. Don't use L'Hopital's rule, please. Master something. If you use L'Hopital's rule, you get 1 over 2. You can solve directly. It's not hard again, but I don't want to use L'Hopital. So keep this for now. Now let's move on. Now this guy, limit as x tends to infinity of ln x over ln x. So here now we use L'Hopital's. Are we together? So let u be what? Ln x. Are we together? Let u be ln x. So that means if u is ln x, will that do? Okay, there's no problem. Yeah. Let me say, let u be equals to ln x. So here we have ln u over what? Over u. Now, I'm not changing limit now. I want to use L'Hopital. Like, I want to differentiate the upper. Okay, let me write it like this. You get what I'm saying now. If limit as x tends to infinity of ln x over ln x. Some people say ln x cancel ln. I pity you. So now, using L'Hopital, you differentiate if I want to differentiate the numerator, so let me just assume that y equals to ln x. I want to differentiate the numerator. Are we together? So to differentiate in the numerator now, I can say let my u equals to what? Ln x. Then du over dx will be what? 1 over x. If my u equals to ln x, that means my y equals to what? Ln u. Now I say let u be ln x. If y is ln x, that means y is ln u. Now dy over du will give me what? 1 over u. If you differentiate ln x, it's same thing as 1 over x. Is that clear? So ln u will give you 1 over u. Let me come again. If y equals to ln x, I say let u be what? Ln x. That means your y is now what? ln u. So du over dx will give you, if you differentiate this, you get 1 over x. Now dy over du will give you what? 1 over u. And product rule, chain rule rather. Chain rule says dy over dx equals to what? Dy over du times what? Du over what? Dx. So that means it's going to give us 1 over u times 1 over x, which is what? 1 over what? Ux. And since our u is ln x, so we have x ln x, ux, and u is ln x, so we have x ln x. So this one change to limit as x tends to infinity of, if you differentiate this, you get what? 1 over x ln x. If you differentiate ln x, you get what? 1 over x. So it's equal to limit as x tends to infinity of 1 over x ln x divided by 1 over x, that's times x over 1. So x cancel x, so it's equal to what? 1 over what? Ln x. So you can put your what? Infinity. So as x tends to infinity, you have 1 over what? Ln infinity. I want to get something here. Ln infinity is actually not a very big number. It is not. But the answer tends to 0. 1 over ln infinity tends to 0. Take note of that. Yeah. It tends to 0. Ln infinity is infinity. So 1 over infinity equals to 0. So our answer is 0 for that one. There are some questions left. There are still much, but I'm actually not feeling fine. Probably in the part 4, I will do them. I'm not feeling fine at all. In the part 4, I'm having kata. In the part 4, I'm going to solve them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I still have 15 questions more. So sorry. I will do them in the part 4. Just the 15 questions alone. I will solve them in the part 4. This one now is direct. I've given you the standard limit this thing. All this one you can still solve them. Okay, let me make the video up to 1 hour. Let me do this. Theory. Limit as x tends to 0 plus, that is 0 from the right, of x ln x is going to give us what? It's same thing as, x is same thing as limit as x tends to what? 0 plus of what? Ln x over 1 over x. Am I right? Yeah. Yeah. If this one, you see, ln x divided by 1 over x is same as ln x times x, which is s ln x. Do we get? So that's that for that. Now, if you use L'Hopital's rule, it becomes limit as x tends to 0 plus. If you differentiate ln x, what do you get? You get 1 over x. If you differentiate 1 over x, what do you get? V du over dx minus u dv dx over v square. So if you differentiate 1 over x, you get minus 1 over s square using quotient rule. Are we together? So this gives us limit as x tends to 0 plus of 1 over x divided by 1 over x, that's multiplied by, divided by 1 over x squared, that's multiplied by s squared over 1. Don't forget this minus. Are we together? So x here 1, x here go. So we have what? Limit as x tends from 0 plus of what? Of minus x. Yeah, I'm right. The answer is still 0. Are we together? If you put your 0, you still get your 0. So that's that for that. Yeah, that should be correct. Now for this one, the standard limit I told you, as x tends to infinity, that one tends to, come and see it. Yeah, if you have this pattern, as limit as x tends to infinity of 1 plus n over x raised to power s is equal to what? E raised to power n. But here, since our n is 1, the answer will be e. Are we together? So the answer here is equal to what? E. That's the answer. But we still want to solve it. Let y be equals to what? Limit as x tends to what? Infinity of what? I'm having great kata. So take ln of both sides. We have ln y equals to what? Limit as x tends to what? Infinity of what? Ln 1 plus 1 over x raised to power x. So it becomes ln y equals to limit as x tends to infinity of what? X, this x will come down. X ln 1 plus 1 over x. Is that clear? So, and don't forget, so this becomes ln y equals to what? Limit as x tends to infinity of x. I'm coming. So, sorry, before this place, this 1 over x, you can say let me write it here. Let u equals to 1 over x. If u equals to 1 over x, as x tends to infinity, that means u will tends to what? 0. Because 1 over infinity equals to 0. If you say let u be 1 over x, and since x is tending to infinity, 1 over infinity, that means u will be tending to 0. So the limit can change to, so you can have ln y equals to limit as u tends to 0 of what? Since your u is 1 over x, if you make x the center of the formula, x will give what? 1 over u, right? So x ln, and our x now will be what? 1 over u. You've changed the limit from x to u. 1 over u ln 1 plus u. Since your u is 1 over x, x will give 1 over u. Do you get? So don't forget, as u tends to 0, ln 1 plus u equals to u. Do we remember? That means so ln y equals to what? Ln y equals to, I think we can have shade TML. Okay. Ln y equals to limit as u tends to 0 of 1 over u times limit as u tends to 0 of what? Ln. Okay, should I do it now like that? Ln. I'm trying to check something. Ln 1 plus u. This 1 over u will give me 1 over 0. I don't want to have 1 over 0. Does it mean, I'm trying to confirm something. Does it mean I can put this thing directly? Oh, sorry. I don't need to split it. I don't need to split it. Sorry. So we have ln y equals to limit as u tends to 0 of what? Ln 1 plus u over u. Don't forget the standard limit. I gave you a standard limit that this equals to 1 if your u is tending to 0. Do we remember? Yeah, I gave you that standard limit. That if your u is tending to 0, where is it? See, this equals to 1. It's a standard limit. So this guy now, as your u tends to 0, ln 1 plus u over u tends to what? 1. So your ln y now equals to what? 1. Exponent both sides. E raised power ln y equals to what? E raised power 1. So y, e raised power ln y is y equals to e. You can see we get e. So that's that for that. So for this guy, I want to solve this one too. This one is kind of, I'm coming. There's a way I want to attack this. This is also in form of this, but you just have to apply some kind of thought, like thinking, to just make it resemble something like that. I think you have to wait till the next video. So sorry. Don't forget to like and subscribe. I'm sorry, this part 3 is kind of, I'm not actually feeling fine. And I want to make sure that I fulfill my words by making it every day so that we not miss it. So tomorrow, part 4, and during our live YouTube, when we start our YouTube live, like part 5, we make it live, like virtual class, like there will be interaction. You'll be able to ask. I'll be teaching. You'll be seeing what I'm doing, and you will be able to ask questions. Then I will answer you. It's going to do a lot. So we are going to talk about all these standard limits. So please don't forget to like and subscribe. Thank you very much.